Okay, in this video we're going to talk about hemostasis. This is a fancy word for how we stop bleeding. Again, slides 35 through 49. Hemostasis refers to the stoppage of bleeding. Now there are three parts to this, and we're going to look at them. Now again, it says these mechanisms are most effective in small blood vessels. Injuries, and that should make sense. When you get some injuries that involve damage to larger vessels, that can be very deadly. So the first part of this is called vascular spasm. We mentioned this in the last one about platelets and the plasma. We talked about this, how serotonin was released. But what happens is when we have a break in one of the small blood vessels, the smooth muscle in the blood vessel will contract as a reflex, and it contracts what we would say upstream. So if I draw this here, and again, forgive me for using this, it's tough on a laptop. So blood is flowing this way, right? And so I've got blood that is leaving here. If I have a point, let's say here, we'll say this is B, and this over here is A. And I'm going to just ask just for a second, and then I'll tell you, of course, but which one of these do you think needs to contract in order to limit the amount of blood flow? So if I sit here just for a second and give you time to think about it, hopefully you know it is at A. Because if I contracted here, I would have pressure built up and it would increase blood loss. So this is going to kind of squeeze down in between here, and it's going to limit the blood that's flowing through. So that helps limit the blood loss. So blood slows quickly. I'm going back up to this part. Blood loss. It slows blood loss very quickly because it starts limiting the amount of blood into that area. It's triggered by the stimulation of the blood vessel, the wall, the pain receptors, and the reflex. And it's a short period of time, relatively speaking. It's going to be, it's up to 30 minutes. But while this is happening, we're going to have the other two start to form. Excuse me. So serotonin, again, is a big part of this. It helps cause vasoconstriction and further helps the loss of blood. So the vascular spasm is just kind of a reflex. I have something happen here, and then behind that spot, I'm going to have a little contraction of the blood vessel walls to help slow the flow of blood in that area. The next one is called the platelet plug formation. Now this is going to happen as the tear, or whatever you want to call it, in the blood vessel happens. There's going to be little bits of collagen fiber. Collagen fiber, again, if you remember in 210 when you were looking at the connective tissue, you had the different types of protein fibers that were in there, and one of them was collagen. So imagine taking a t-shirt and ripping it, and you have the little cotton fibers along the edge. I'm not talking about cutting it with some scissors or whatever, but ripping it, you're going to have these little fibers that stick out. So in this, you're going to have these little collagen fibers that stick out. And as this happens, as these little platelets pass by there, they will start sticking to that collagen. Now, as that collagen starts getting stuck in there, it's going to help plug that little gap. But while this is happening, this blood coagulation, is the one that's really going to be a big factor in this. Now, I didn't set this up, and I really should have. I want you to remember in your mind this picture and this yellow on here. I wish I would have set it up on here to kind of bring this picture later on to see it. But you can see these are the red blood cells in here, and they are surrounded by this yellow webbing. I want you to think of that yellow webbing and keep it in your mind. Now let's go back up here. Blood coagulation, as it says, it's the most effective mechanism of stopping bleeding, of hemostasis, and it occurs in 5 to 15 minutes as this is going on. This is when a blood clot is formed, and the blood clot is going to be a series of reactions that are going to happen, and it's called a cascade, and it is a very complicated part. And we're just going to look at the end part of it, but this cascade reaction is going to be initiated in one of two different methods. One of them is going to be extrinsic and one's intrinsic. Hopefully you can kind of figure out by the names of them that extrinsic are happening outside of the vessel. If something happens inside of the vessel, it's intrinsic. Now, there's a lot of chemicals involved, and they're called clotting factors. Again, if you ever donate blood or have to receive blood, the plasma and clotting factors have been removed from the blood that is donated. Vitamin K is a big part of it, and of blood clotting. Now, as we go through, we're going to find this guy that we looked at in the last one about platelets and plasma. Fibrinogen is one of the plasma proteins, and I told you that OGEN means it's a precursor. And fibrinogen, if I remove OGEN, I'm left with fibrin, and that's what fibrinogen is a precursor to, as it says right here. And that's what these yellow threads are. They are fibrin. And so what's happening here, and since I've got this picture here, I'll just use it and we'll talk about it as we go along. Fibrinogen is constantly being produced by the liver. Fibrinogen, I hope you, in your mind, I want to give you a little mental picture. I don't know if anybody remembers or knows, there used to be, a little stupid joke where you'd have this little can of peanuts, and inside of it would be this little coiled up spring like a snake, and then you'd get somebody to open the top of it, and then this snake would spring out. And it's like, woo, and people thought that was funny. Well, instead of this little idea of this coiled up snake, imagine that inside this little can there's a cast net. I mean, people have seen or know what a cast net is. If you do, I hope you can kind of picture it. If you don't, here's what it is. It's this big net with weights at the end. It's a big circle, and it's got a string attached to it, and it's for fishing. And people will take it and throw it, and there's a really fine art to being able to do it. If you don't know how to throw a cast net, it can be really ugly at first. But people that know how to throw it, when you throw it, it spreads out and it lands on the water, and then the weights sink it down, and anything in that net, when you grab that string and pull it, the weights at the end get pulled together, and anything in that net you catch. Cast nets are a pretty cool way to fish without a lot of, but I mean, I shouldn't joke about it, but man, I remember when I was learning to throw a cast net, there was several times I almost hurt myself. But imagine a little can with a cast net in it. That is fibrinogen. When it comes in contact with a few things, and we'll talk about that in a minute, the fibrinogen turns into fibrin, and fibrin is the cast net. So imagine that all of a sudden this little tight molecule gets sprung open, and it is this big net of things, and it goes out and it catches red blood cells. That is exactly what that yellow is. It is fibrin. And at one point in time, that fibrin, all that yellow, was in a thing that probably was so small you could barely even see it, if it was on that picture. All right, so that's kind of a cool deal, but we're going to get into that a little bit more. So this is the three parts to it. Vascular spasm, just a reflex to kind of pinch the walls of the blood vessel that is kind of limit the blood flow to the area that's been hurt. The platelets are going to flow through, and they will start sticking to the collagen, the torn collagen pieces of the broken blood vessel, and they will form a very basic plug. And then we will have a series of events that we're going to look at in just a second that lead to the formation of fibrin. And this fibrin is like a cast net. It'll start catching the red blood cells, and this is what forms the thing that we know of as a blood clot. So if we're looking at the extrinsic clotting mechanism, again, it's going to be when blood coming in contact with tissues outside of the blood vessels. So there's a little factor that we're going to look at. The damaged tissue release this thing called tissue thromboplastin. It is also referred to as simply factor 3. I am not worried about you knowing that right now. Again, on this little complicated process, there's a lot. I mean, this is a very complicated process. So we're going to look at one particular part. Right now, what I want you to know, extrinsic happens outside the blood vessel. But I'm going to go over a little bit of it. So the cascade begins after several little changes of things. Thrombin is going to be used to convert fibrinogen into fibrin. And again, thrombin is something we're going to look at here in just a minute. Now, it's fibrin, again, are these threads that stick to the damaged blood vessel surface, and they start trapping the blood and the platelets, and that's what forms officially a blood clot. This is an example of a positive feedback, and again, positive feedback is a very limited thing, because what positive feedback says is if I have a set point and I have something moving away the set point, I am going to increase what's happening. So when the little bit of blood clotting happens, there's going to be things that encourage more blood clotting and more blood clotting. Now, there it is very tightly controlled, because if it wasn't the first time you nicked yourself, you would have you still to this day would still be clotting and increasing. You wouldn't live very long. And that's why positive feedback mechanisms in general are a sign of pathology. Extrinsic is when it can start without tissue damage. It's activated when blood comes in contact with foreign surfaces. This is going to be generally inside I shouldn't say generally, it's going to be happening inside the blood vessel. This is going to be a lot of times an issue with damage on the inside normally, but most of the time we're talking about an abnormal clot. But intrinsic can happen on the inside, and that's what I want you to know with that. So this is the steps, basically. You got a trigger, initiation, then you got a bunch of reactions that happen. Basically, we're going to look at from prothrombin down, but we'll see this in just a second, the little flow chart, which is here. Now, this, again, I should have increased this a little bit, but this is extrinsic and intrinsic. As they come down, we have a little area from a certain point that on down is called the common pathway. That's basically what I'm going to look at. And what I'm going to start with is I'm not worried about factor 10 and factor 5. I'm going to start with prothrombin activator. And I did a bad line there. So prothrombin activator. Now, pro means precursor. So prothrombin is a precursor to thrombin. So prothrombin activator is going to take prothrombin and activate it by turning it to thrombin. That should be something that makes sense. Prothrombin activator activates prothrombin. And what activating prothrombin means is it turns it from prothrombin to just thrombin. From that point, thrombin is going to that is what's going to open up that packing peanut, that packing cast net that I was talking about. It's going to take fibrinogen and turn it to fibrin. Fibrin is going to be that little mesh that's going to be released and start catching the blood cells and form the clot. Now, I want you to know, starting at prothrombin activator. All right. Now, I'm telling you, I don't get to make the test questions. I'm using the test bank. I don't know exactly how it's going to happen, but I expect you to know. I don't know how I shouldn't say I don't know how it's going to happen. I don't know what their questions are. I expect you to know starting from prothrombin activator. So prothrombin activator activates prothrombin and turns it to thrombin. From thrombin is going to take fibrinogen and turn it into fibrin. So thrombin is basically the guy that opens the little jar with the spring-loaded cast net, and it turns fibrinogen to fibrin, and then fibrin forms the blood clot. Now, this is the list of things. I just put it on here because I want you to know, and this isn't even all of it. This gets into, all this different stuff. As you can see, this is one of the big things. I'm just going to point out that almost all of it is going to be made or synthesized, as it says, in the liver. Not every one of them, but almost all of them. And it's not just for the clotting factors, but there's all kinds of little things that your body, your liver is sending out into your bloodstream. It is organizing and keeping things in line that you can't even believe. But that, again, not worried about any of this. I'm not trying to freak you out. I just wanted to point out how important the liver is. In the digestive system, we're going to talk about the liver briefly, and it's just touching the surface. It's talking about its creation of bile, but just want to show you an example of how important and how much the liver does just in this one part. So now once we have blood clots, this fibrin is an amazingly strong molecule, a structure. It is incredibly strong. And so if once we have it and we need to dissolve it, there's hardly anything in our body can dissolve it except for one thing, and our body makes it when it's time, and it is called plasmin. Plasmin is released once the tissue is healed. It's going to release the new tissue will release plasmin. It digests the threads, and it dissolves the blood clot. And so that's how it works. Now, we can have abnormal blood clots. The next one here, thrombus, is an abnormal blood clot, and if it breaks free, then it is called an embolus because it's a blood clot that's moving through. Now, this thrombus, the thing that's so awful about the thrombus, because we're talking about this positive feedback, if a thrombus forms, it's forming when it's not supposed to. All right, it's rubbing up against some atherosclerosis or some kind of plaquing that's in the blood wall, the blood vessel's wall, and so it mimics the torn collagen fiber, so it triggers this little mechanism to form a blood clot, and we call it a thrombus. Now, since there's no damaged tissue to heal and release plasmin, there's nothing to dissolve the fibrin, and so that's a pretty bad situation. But going back up to the top, after the blood clot forms, it retracts and it pulls the edges of the broken blood vessel together. Now, what's happening here? Water is being removed, and so it's squeezing it together. Now, when we donate blood, a lot of times they will take the plasma and store it, and we call that serum. Now, what serum actually is, it's not just plasma. It's plasma when they remove fibrinogen and pretty much most, if not all, of those clotting factors we just looked at. That's what serum is. So if you are dehydrated, they can give you fluids. A lot of times it can be serum, and it's simply just plasma without the stuff that causes clotting. Now, platelet-derived growth factor stimulates the smooth blood muscle cells and the fibroblasts to repair the damaged blood vessels. So when it goes through here, the platelets are going to start causing the release of this growth factor, and it is specifically targeted to the smooth muscles of the blood vessels and the fibroblasts in that area to repair them. So we talked about a thrombus and an embolus. So let's talk about what they are. Thrombosis is a disease if the blood clot, where the blood clot develops in a vessel supplying a vital organ, such as your brain or heart. Now, this is commonly referred to as kind of like this, I won't say a stroke, but this can lead to a stroke. As you see here, this is a narrowed plaque-filled artery. And so as the blood's flowing through here, the plaque is going to be actually kind of sharp, and it's going to mimic those collagen fibers. And so I'll start forming clots. If that clot starts blocking a vital organ, that is called thrombosis. If it blocks the tissue from the blood getting to the tissue will die fairly quickly, and that is called infarction. So a myocardial infarction, myocardial means heart, infarction means tissue death. Myocardial infarction is the name for a heart attack. It's because the muscles of the heart have the blood blocked to them, and it dies. Embolism is when this blood clot, if it breaks free and it starts traveling through the blood vessels, in general, the most common place that it's going to start accumulating is going to be in the lungs, and that's called a pulmonary embolism. But embolism is just when it blocks it breaks free, and then it blocks a vital organ. Now, atherosclerosis is the accumulation of the fat on the inside, and that is probably the most common way to form thrombosis. So the smooth lining of the blood vessels discourages accumulation of platelets and clotting factors. As the clot forms, fibrin latches onto the thrombin and prevents the clot reaction from spreading. So as it goes through, remember you got prothrombin turns to thrombin, thrombin takes fibrinogen and it turns it into fibrin. But in that process, thrombin actually will bind to the fibrin, and that prevents that thrombin from going down and causing it to happen at other places. So it's a little bit of a preventative mechanism. It's actually a really good thing. And it just amazes me how complex all this stuff is. And I mean, I just don't see this happening by chance, because if this didn't happen, if this process, the change from fibrinogen to fibrin, which is amazing in and of itself, but if it didn't involve thrombin binding to fibrin, then we would have big problems. So anyway, I just think it's pretty cool. I just think the body's amazing. Anyway, antithrombin inactivates additional thrombin by binding to it and blocking its action on fibrinogen. Now, some cells, such as basophils and mast cells, now we looked at basophils. Basophils are the ones that stain blue. They've got histamine and heparin. Mast cells are cells in outside of the circulatory system that are very similar to basophils. Basically, they are basophils, and they secrete heparin as an anticoagulant, and the anticoagulant is stopping, in this case, basically stopping this process, the fibrinogen turning to fibrin. So again, this is a little bit of some of the other things involved in it. As it says, actually, I misspoke in the last slide as I was going through. The heparin is going to interfere with the making of prothrombin activator. So, and remember, that's where we started, prothrombin activator. That's what I was thinking, but I can't believe I messed that up. But anyway, prothrombin activator is what I'm saying I want you to start. It activates prothrombin to thrombin, and then thrombin takes fibrinogen, turns it into fibrin, that cast net. That's a bad drawing of a cast net. Ooh, it looks like a bullseye, a little spider's web, actually. I don't like that. So anyway, and then that's what causes the clot. And that's probably the one I want to make sure that you kind of know.